Okay, so welcome back from spring break. I hope everyone had an enjoyable, relaxing time as much as possible without really being able to go anywhere and everything. So we're jumping right back in this week to our Algebra 2 stuff. I will get quizzes graded as quickly as possible. I enjoyed my spring break as well. This is why they have not yet been graded. So 7.1 and 7.2 we're going to kind of throw together just because we don't want to spend a ton of time with it. You should have seen it in Algebra 1, and I'm just not overly concerned about spending a ton of time with it. So 7.1 and 7.2, it's going to be graphing exponential growth and decay functions. Okay, so a lot of books actually lump this together, which is why I kind of am doing that here. So we have, we need to look at the parent function for exponential growth. So we'll do a little bit with growth and then we'll go to decay. So the parent function for exponential growth. Alright, so the function f of x is equal to b to the x, where b is greater than 1, okay, and this right here, this is the key part, is the parent function for the family of exponential growth functions with base b and then we will look at the general shape of its graph. So what we have here is we're just going to draw a little coordinate graph here, and I'm more or less just going to eyeball it here, but we have something that looks like this, crosses and goes up exponentially. Okay, it crosses here at 0 and so on and so forth a little bit. So sorry about that if it just skipped some there. I'm not sure what was going on. But anyway, so we have the x-axis has what we call an asymptote on it, okay, and normally we label that just kind of with a dot, 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 meaning that the graph can't cross that. Okay, so this is an asymptote there. And obviously we don't spend a ton of time with domain and range in here, but the domain of this is all real numbers, and remember we label that as an R like that. It's kind of a two-pieced R there, and then the range is y greater than 0. So that means that anything up here above 0, but it never goes below because it can't cross this asymptote there. So just keep that in mind. Alright, so the way we're going to do this, we use a table. So I'm going to go over here and look at a few problems. You're not responsible for much out of this section, like I said, so just looking at a couple problems. Okay, you're just going to graph the function in your homework. Okay, you graph the function, and then just to get in the habit, you're going to state if it is exponential growth or decay. Okay, so just to get in the habit, because on a quiz, I'll just give you a function and you'll be responsible to tell me that. Alright, so something like, we're going to keep it pretty basic. Number 6 is where we'll start. We're just going to do about 2 of these. Y is equal to 3 to the x. So with this one, okay, we draw a table, and when we do that, we have our x values, our y values. Our x values, these will be the values that you always use. Okay, we do -2, -1, 0, 1, 2. Okay, so you will always use these 5 points. Okay, always use 5 points when you're doing it, and it's going to be these ones, and I'm very picky about this, okay, because everybody's graphs look the same. Okay, and then ultimately over here, we're going to graph it. So, all you do is you take these points and you plug them in. Okay, so in this case here, the first thing we're looking at is 3 to the -2. And hopefully you recognize that that is 1 over 3 squared. And it just froze again, sorry about that. Which is 1 over 9. Now we have, in this column, 3 to the -1, which hopefully you recognize to just be 1 over 3. So that's 1/3. 0, you end up with 3 to the 0. And so that's just 1. Hopefully you remember that from rules of exponents. Here we end up with 3 to the 1, which is just 3. And here we get 3 squared, which is 9. So now you come over to your graph here. Okay, and it doesn't have to be anything perfect. Okay, I'm out to 9, and I'm just going to label where the points that I need are. Okay, now, obviously, we have some very, I just did this backwards. Ignore this. I need to scratch that out. My fault. I'm looking at the y values, and I should be looking at the x values. Okay, x values are -2, -1, 0, 1, and 2. So really, what we can do is we can actually just draw the top of this because we're not going below. In this case, we can see that. So out here, -2, -1, 0, 1, and 2. And see, this is why you really have to pay attention, because I got distracted and wasn't paying attention. Okay, and then as far as this goes, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm going to label the 1, I'm going to label the 3, and the 9. Okay, just to kind of help me eyeball where my points are. So now, at -2, I'm at 1/9. So I'm just barely above the line. At -1, I'm at 1/3, so I'm a little higher than the last point, but not by much. Okay, at 0, I'm at 1. Okay, at 1, I'm at 3. And at 2, I'm at 9, so I'm all the way up as best as possible. I clearly missed my dots a couple times there, but that's okay. And this would be exponential growth. Okay, so again, it's really important to pay attention because otherwise you'll end up with something like I did here where I wasn't paying attention and I put the y values on the x-axis. Not what I was looking for. This is what it should look like right here. Okay, and this is why everybody does it the same way. Okay, -2, -1, 0, 1, 2, because that makes it really easy to follow when I grade stuff. And sometimes, okay, this point will end up being really large. Okay, and occasionally this one will too when we have a decay function. If these are really large, okay, so you end up with something like, you know, basically anything greater than 10, you can ignore this point. You do not have to graph this point if this is greater than 10. Okay, you just have to graph out to whatever this one value is. I think we might see one of those here in just a second. We'll do number 10, and then hopefully that way you can kind of see what that looks like there. Alright, number 10. Hopefully I have room to do this here. Alright, 10 is y is equal to 2 times 4 to the x. So again, I'm going to set up my table here with negative 2, negative 1, 0, 1, and 2. So now notice that when we do this and we plug in the x values here, we also have to multiply it by 2. So now I end up with, in this first one, 2 times 4 to the negative 2. Hopefully you recognize this as 1 over 16, so it's going to be 2 times 1 over 16, which is 1 over 8. Okay, just by canceling, just basic algebra here. This one is 2 times 4 to the negative 1, which is 2 over 4. Okay, or 1/2. At 0, okay, we have 2 times 4 to the 0. Well, 4 to the 0 is 1. So we have 2 times 1, which is 2. Now over here I have 2 times 4 to the 1. 4 to the 1 obviously is just 4 times 2 is 8. And now this one we're going to end up with a big one. So 2 times 4 squared. Well, 4 squared is 16. So 2 times 16, that's going to be 32. 32 in this case, okay, we do not graph this point. Do not graph. It's a large number. Sorry, that's kind of hard to read. Do not graph, it's a large number, so we're not going to graph that one. So this time when we graph it, I'm going to pay attention this time and get my values correct. Okay, this time when I do it, I have negative 2, negative 1, 0, 1. I'm not even going to write the 2. The value's just too big. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 is the highest that I need to go. So, and let's see, I need to label the 2 and the 8 there just so I can kind of see where I'm at. Alright, so at negative 2, we're at 1/8, so just barely above the line. Okay, at negative 1, we're at 1/2, so I'm a little bit higher up. At 0, I'm at 2. At 1, I'm all the way up at 8, and like I said, the reason we don't do the 2 is because that'd be somewhere way up here on my paper, and that's just crazy. So, we're not going to graph that point. So here, you can come up and meet it. Alright, so that is, again, I should label exponential growth. Alright, so now let's look at the stuff. So that was 7.1 technically. Okay, 7.2. Let's look at, we're going to jump in and look at the parent function for that one here in just 1 second. Gotta find the page. Alright. Sorry about that. Alright, so parent function for exponential decay. Let's see if I can get this focused in here. Went out of focus. That did not help anything. Throw this under here really quick. You can just ignore what it has written on it. I have to do this to focus it. There we go. Now we should be focused. Sorry about that. The thing has been acting weird sometimes when I go to focus it. Alright, so back to the parent function for exponential decay. So with this one, you have the function f of x is equal to b to the x. So same function, but here the important part is where 0 is less than b less than 1, meaning b is either going to be a decimal or a fraction, unfortunately. Okay, is the parent function for the family of exponential decay functions with base b. And we're going to look at the general shape of the graph. Okay, again, it's going to pretty much look the same. It's just flipped. So this here, and we still have our graph coming through like this. This is still an asymptote. Okay, the graph is just flipped, so we have 1b here, right here is still 0, 1, and this is still f of x is equal to b to the x, but 0 is less than b less than 1 is the stipulations that we're putting on that one there. Okay, and same domain and range. Domain, all real numbers. Range, y is greater than 0. Okay, so really no different in that realm, just that stuff's more of just an informational thing for you. Alright, so graphing these, again, we'll just do like 1 or 2 of these. Actually, we'll probably just do 1 of them. Yeah, we'll just do 1 of them. So we're going to do number 8. Y is equal to 1/3 to the x. Okay, so again, in this case, we're going to make our table, our xy table. Same points, -2, -1, 0, 1, and 2. So when I plug in -2, so I get 1/3 raised to the -2. Well, I should recognize that this negative flips my fraction, giving me 3 raised to the 2 then, which is 9. So that value is 9. Okay, and this is a value that, like I said, sometimes it could be really big, and you wouldn't have to graph this one with these functions. -1, 1/3 to the -1. Should recognize that just flips my fraction, which in this case gives me 3 to the 1, which is just 3. Over here, I get 1/3 raised to the 0, which anything raised to the 0 is 1. So that's just 1. 1/3 raised to the 1. Well, that just stays 1/3. And 1/3 squared leaves the fraction as is, but the squared goes to both pieces. 1 squared is still just 1. Over 3 squared is 9. So it's 1/9. Okay, so these ones go in the opposite direction of the other ones. Okay, these ones go in descending order, the other ones go in ascending order. So now I could graph this following the same procedure. None of these numbers are too big, so I'll graph all of them. -2, -1, 0, 1, and 2. And all the way up to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is 9, that's 1. And 3. So this is actually the reverse of the first problem we did, which I'll put that back up in just a second so we can compare. So here we have a -2, we're all the way up at 9. At -1, we're at 3. At 0, we're at 1. At 1, we're at 1/3, so just below, or sorry, just above the 1, and then 2 is just a little bit below where that one was, because it was 1/9. So now our arc comes down like that. Okay, sorry, that kind of flattened there. There we go. Okay, and again, all stays above that axis there. Okay, and in this case, then we would write this as exponential decay. Okay, so go back to the very first problem that we worked. Let's see the best way to put this up. Let's bring this down some. Alright, so notice here, okay, this problem ends up being the exact opposite. Okay, so this was 3 to the x, so we went 1/9, 1/3, 1, 3, 9. But in this case, we had 1/3 to the x, so we went 9, 3, 1, 1/3, 1/9. Okay, so you kind of follow the pattern here. Okay, if your numbers don't make a pattern like this, something is wrong. Okay, they should always have this pattern about them when you do problems. So that's all for that. So let me give you a couple homework problems here for this section. So for 7.1, you need to do number 8 and 9. And from 7.2, I just would like you to do number 7. Okay, so that's all you need to do for this section. Okay, that shouldn't be too bad. And because one of these is even, let me know if you have any questions about it. These probably won't look exactly like they do in the book, just because I do kind of modify my instructions a little bit for this section. But if there's any questions, let me know, and I'll try to get answers to you as quickly as possible.